Exponential function. An exponential function is a function whose equation can be put into the form f of x equals ab to the x, where a cannot be equal to 0, b has to be greater than 0, and cannot be equal to 1. The constant b is called the base. So we have our equation, exponential function form, f of x equals ab to the x. And keep in mind this is in function notation. So therefore we read it as f of x from the left side. Remember, it just should be just y equals. And in this case it's still the same. You could technically replace the f of x with a y. You could say y equals ab to the x. But let's try to use f of x. So f of x equals. But otherwise it's similar to saying y equals. Let's realize that we have a coefficient, and the coefficient just means number before, there it is, it's the a, it's the number before the base. And the base, of course, is the v value in this case. It could be a number or it could be a variable in some cases. But the base is the v. And of course we have what we call the exponent, the x. So we have a coefficient, the base, and the exponent. And let's evaluate using the following. So we have two equation statements there. F of x equals 2 times 4 raised to the power of x, and g of t equals 3 to the t. And for the first case, it asks for f of 3. And for the second case, b, it asks for f at a plus 2. Do realize this. Does it ever ask in this case g of t? Well, probably not in this case for those two examples, right? But we'll do a few more where it will ask for g of t. So the fact is, we're only going to do for a and b f of x equation format, okay? So let's try it out. For a, let's copy down our formula, basic formula, f of x equals 2 times 4 raised to the power of x. And there's our formula that we're given. We're not doing g of t because it doesn't ask us to use g of t for a. For a, it asks us only to do f of x. And so therefore, f at, in this case, for a, they asked us to use 3 when x is 3, agreed? So we know the x value is 3. So wherever we see an x, we're replacing the x with a 3. There it is. So 2 times 4 to the third. Do remember orders of operation. Orders of operation say we have to do exponents first, right? Then multiplication. So we can't multiply 2 times 4 yet. We gotta do the exponents, 4 to the third. Or in other words, 4 times 4 times 4. 4 times 4 is 16, 16 times 4 is... this is where your calculator could come in handy, right? So, your calculator. Recommend you turn on your calculators. Remember the caret key is right underneath the clear button on the right side. Right underneath the clear button, TI-84 should be similar, except if you push the caret key on your TI-84, it doesn't show a caret key. Instead, it raises it up for you. So you won't see a caret key, you see just a smaller number and up higher for TI-84s. So 4 to the third, there we go. Hit enter. For TI-84s, if you want to add more stuff on the TI-84, such as plus 2 times something, you'd have to push forward to make it come down from the exponent, okay? TI-83s you don't, you just continue right on typing. So hit enter, and now it gives you 64. So in this case, 4 to the third gives us 64. So there we go. So far, f at 3 equals 2 times, now we got 64. So 2 times 64 will give us, 4 times 2 is 8. 6 times 2 is 12, so 128. Or we can always double check once again, do a quick check with your calculator, right? Don't forget, it's a very useful tool. So 2 times 64, yep, missed the number. There we go, 128, there it is. We verified it, it's 128. So remember, practice your multiplications, and just as well, practice using your calculator. So f at 3 equals 128 is our final result. Pretty straightforward in this case, agreed? Just remembering our OR operation though. So let's try the second one, B. So for B, we have f of x equals 2 times 4 to the power of x. Once again, using the same f of x equation. Once again, there's no g of t asked question on this, right? Instead, they ask for f at a plus 2. So f at a plus 2 is equal to, well, remember, the a plus 2 represents the x. So wherever you see an x, you're going to substitute a plus 2. There it is. Where the x is, we substituted a plus 2. So we have 2 times 4 to the a plus 2. Whoops, it's not going to be as straightforward as the previous one, right? But it shouldn't be too complex. Well, let's see. Have we seen something that could help us simplify this a little bit? Hey, how about this? We have product properties, right? Whenever we multiply with the same base, we add the exponents. It looks like that's occurring here, agreed? A plus 2 is being added as an exponent. So we could probably go in reverse order to be able to simplify in this case. Rather than combining them as addition, separate them as a multiplication. So once again, reverse order should work for this one. So let's try it out. F at, we have in this case, a plus 2 equals 2 times 4 raised to the power of a times 4 raised to the power of 2. So going in reverse order. Keep in mind I could combine this since it's the same base, same 4. We can combine for the a times 4 squared into 4a plus 2 again. But we don't want to, right? Notice we can simplify the 4 squared. 4 times 4? 16, right? So f of a plus 2 now is 2 times 4 to the power of a times 16. Because we simplified 4 squared. 4 times 4 gave us 16. And now we simplify the next step. Meaning I can't simplify 4 to the a. We don't know what a is. But we can multiply because it's pure multiplication. So we can multiply 2 times 16. Double of 16 gives us 32, right? Or 2 times 16 gives us 32. So f of a plus 2 equals 32. That came from 2 times 16 times now 4 to the a still. So that's as far as we can get since we can't multiply 32 times 4. Or so operations say we must do the exponents first. So I must go 4 to the a before I can multiply the 32. So in a sense, this is as far as we can get for this particular problem. That's our answer. Okay, let's try another example. Do notice, those previous examples came from this set of examples. The first two there, A and B. So, evaluate using the following. Notice in this case, we're going to use the next one, which is C, g of negative 3. So for C, we're finally using the g of t formula, agreed? And it's right above. So g of negative 3, and replacing the t value, wherever we see it, with the negative 3. But once again, do notice, we have a negative exponent. We don't seem to enjoy negative exponents. So let's try to convert to a positive by doing the reciprocal, meaning since it's a whole number, put it over 1. So 1 over 3. And once again, remember it's negative 3. So we're doing the reciprocal converts it to a positive exponent. So 3 to the 3 means 3 times 3 times 3, agreed? 3 times 3 is 9. 9 times 3, 27. So g of negative 3 becomes 1/27. Do remember, you can do a quick check with your calculators. Go ahead and turn it on, clear anything you might have. And we can do 3 to the power of, or 3 caret key, for t84, once again erases it up. And let's put 3. 3 to the power of 3, 27. Or we could have actually done this one from the beginning. So 3 caret key, open parentheses, put a negative sign. This has to be a negative sign. The one that's next to the enter button and not a subtraction sign. So use the negative right next to your enter button. There we go. Negative 3. Close your parentheses and hit enter. And there is your answer. 0.037, 137, 037. If we take 1 divided by 27, this is just to check our answer, it gives us the exact same value. So it works. It gives us the exact same value for that case. So there's our answer for this case. G of -3 equals 127. So we have the question, G of -3, and the answer is 127. So in other words, when the x value is -3, the y value result is 1/27. Do remember, the G of represents the y. So hence the reason why I'm saying y equals 1/27. Just to reference back to basic format. So let's try the next one. D. D takes us once again to G of. G of, in this case, 2a. And this is raising 3 to the power of 2a because that was a t value, right? So replacing the t with a 2 times a. So 3 to the power of 2a. How do we simplify this one? Because we have a number and a variable. Have we seen anything similar to that? Hey, look at that. A power over a power. Agreed? So when we have x to the m and then raise it to the n, the equivalent is to say x to the m times n. In other words, it multiplies together. But we can always go in reverse order. Agreed? We have a exponent, so base raised to 2 multiplying powers. We could basically space them out, or separate them out, in other words. So we have G of 2a, and we can write this as 3 to the power of 2 and then to the power of a, or we can space this out in the form of saying 3 to the power of a and then to the power of 2. But do notice the second option, the one that's after the or, may not be the best choice because we would have to do 3 to the a first. 3 to the power of a, well, we wouldn't be able to simplify at all because we don't know what the a value is. On the other hand, the first format, 3 to the power of 2 or 3 squared, we can do that one. We can simplify it. 3 squared means 3 times 3, which will give us 9. So yeah, that would work. So G of 2a, using the first format, 3 squared gives us 9, 3 times 3 gives us 9. And then it's raised to the power of a. And from here we can't simplify any further. So this is technically our final result. So we may not always get a number value, sometimes we get another expression. So G of 2a equals 9 to the power of a. Or in the old style we would say y equals 9 to the power of a. Once again, question, G of 2a equals 9 to the power of a. So let's try the last example there, E. For E, it's f of 2 minus a. And our expression, once again, we got to use the equation f of x equals 2 times 4 to the power of x. So in other words, we're replacing the x in this case. So replacing the x with 2 minus a, there we go. A little tricky again, because that's 2 minus a. So we use the power over power. That's the previous one. We use product properties. This is subtraction, so that implies it's an quotient rule. Agreed? It's a quotient exponent rule. So h to the 6 divided by h to the second, as an example, is equivalent to saying h to the 6 minus 2. It looks like what we have here on the right side, right? But we want to be able to simplify this. How do we simplify this? Well, we could probably go in reverse order again, agreed? Rather than combining them into a subtraction, we can revert back into division with the same base. The base in this case is 4. So reverting back into a division. F of 2 minus a is equivalent to 2 times 4 divided by 4. And notice now that the 2 is the first one that goes on the top. The a is the one that's subtracting, so the subtraction always comes from the bottom, the division portion. So it becomes 4 to the power of a. And notice it has no negative sign. It's a positive because it's already on the bottom. So the bottom is what makes it a subtraction, meaning it's underneath the fraction sign or it's on your denominator value. Okay, so now let's simplify. 4 squared. 4 squared, 4 times 4 is 16. So we're able to simplify the top. So f of 2 minus a gives us 2 times 16 divided by 4 to the power of a. So there we go, we simplified it. And now we can actually multiply. Do realize that 2 only multiplies once. You're welcome to put a 1 underneath. In other words, this would be 2 over 1 times 16 over 4 to the power of a. And 1 times 4 to the a will be just 4 to the a. And the 2 times 16 is 2 times 16. Double the 16 gives us 32. Yeah. So f of 2 minus a is equivalent to saying 32 divided by 4 to the power of a. Once again, do note, the 2 multiplies only once. And this is our final answer. F of 2 minus a equals 32 over 4 to the power of a. We are complete in this case with our examples.